This video will work through problem 8.4 of Gapenski's Healthcare Finance, 5th edition. Okay, because there's so many calculations here, I'm going to use Excel just to make this a little easier to follow. But we have a static budget, and we start with some assumptions about our static, about our budget, in particular about our number of visits. So we have fee-for-service visits. And so our expectation is that we're going to have 36,000 fee-for-service visits. We're going to have some capitated visits as well. So we think we're going to have 54,000 capitated visits, right? For total number of visits is equal to all right, it doesn't want to cooperate. No, I don't want to do that. There. All right. Equals, let's just do this. There we go. All right. So our assumptions here, we'd have 36,000 fee-for-service visits, 54,000 capitated visits, total of 90,000 visits. Now going to the problem, so the problem gives us the actuals. So it turns out the actual number of fee-for-service visits was 34,000. The actual number of capitated visits, let's see, capitated visits, come on. Okay, so the utilization, okay, it gives us 43,200. So that's 43,200. And so our actual total visits was 77,200. Let's give that. Okay, and remember, flex is based on actual. So so when we get into volume, flex and actual are the same. So that's why I've done that there. Okay, so now we want to calculate revenues. And so we have fee-for-service revenue and capitated revenue, right? And then total revenue. So our fee-for-service revenue was expected to be, let's see. Our fee-for-service revenue was expected to be $25 per visit. So 25 per visit times the number of fee-for-service visits, that's 36,000. So 25 times 36,000 gives us 900,000. And then our capitated revenue was supposed to be, so capitated revenue comes from the number of members that we have. So we were expecting 30,000 members, and we were expecting to charge them $3 per member per month times 12 months. So that gives us capitated revenue of 1,080,000. Let me get this. So our total revenue was expected to be 1,980, right? Our costs were expected to be, so we have costs, we have variable cost related to our fee-for-service, and then we have variable costs related to our capitated patients, and then we'll have total variable, and then we'll have fixed, and then we'll have total cost. All right, so our variable costs for our patients, we expected to have, according to, so if you go to page 266 of your textbook, section 3 works out that variable cost is $15 per visit. So we say that's going to be equal to 15 times 36,000. That's our variable cost for our fee for service. Then same, just because you're a capitated patient doesn't mean it costs any more or less to treat you. So 15 times 54 for a total variable cost of 810,000. Sorry, total variable cost of 1.35 million. I just wrote it and I'm saying the wrong thing. And then we were originally expecting to have fixed costs of 500,000 for a total cost of the fixed cost plus the total variable cost gives us 1.85. Okay, and then profit is our revenue minus our total cost. And so we were projecting $130,000 in profits. So what about actuals? Okay, well, actuals, as it turns out, we earned $28 per visit for our fee-for-service patients. So that is 28 times the number of fee-for-service visits. That gives us 952. And then the capitated revenues. So it turns out that we in fact had 30,000 members. However, we only earned $2.75 PM instead of the $3 expected. But it turns out that there's still 12 months in the year. So our capitated revenues are only $990. So sum that up. And we get total revenues of $1942 was our actual. And now our variable costs for fee-for-service. So it turns out our variable costs were actually $17.72 per member. I'm going to go over here to the side because to put in that variable cost, though, because it turns out that there's a bunch of decimals there that if you round to 1772, you're going to be off just a little bit from the book solution. So it turns out that the variable cost, total variable costs were 1.368 million. And we had a total of 77,200 visits. So it works out to 1772, but if you add some decimals, what you can see is that there's some, right? If you round it to 1772, when you multiply 1772 times 77,000, you wind up with a small variance there. So let's just put that in here. So we're going to use, for our fee-for-service variable cost, we had 34,000 visits times our actual average variable cost, which is this, and we get 602,487. The difference would have been you would have wound up with 602,480. So it would be a little bit off from the book solution. And then our capitated, we did 43,200 visits times that 1772-ish number. So that's 765. 513, and so we sum that up and we get 13.68. And then it turns out that our fixed costs were actually 525. So when we sum up our costs, we get 1893. And so our profit is our total revenue minus our total costs. So we actually wound up earning 49,000. Okay. Whew, now all that done, now let's go ahead and do our flex. So remember, flex, this is this column is equal to the volume volume actual times the, sorry, not volume this column is the static column is volume expected times price expected. This column is volume actual times price actual. And this column is volume actual, which is why we're up here, times price expected. So we're borrowing the prices from the static and the volume from the actual and combining them together to get, forgot to tell Excel that that is not an actual equation, just some letters. Okay, so when we calculate the fee-for-service flex, what we need to know is the actual volume, which is 34,000, times the expected price. So the expected price, going back to 266 here, right? The expected price was going to be 25. So we should have, if we had earned the expected price, we would have earned 850,000 in fee-for-service revenue. Now the capitated is our actual volume is the same, right? So our actual volume was 30,000 times the actual number of months times the original expected price of $3 per member per month. So that's still the same, right, from before, because, and it's still the same because we're using the original price and the actual volume. Well, the actual volume was what we thought it was going to be. The only change was the price. So these are going to be equal as a result. So then we get our total revenues for our flex revenues. So that's 1930. Okay, now we're going to do our variable cost, fee-for-service variable cost. Our fee-for-service variable cost is going to be based on our actual volume, right, times our expected variable cost, and our expected variable cost was 15. So it should have been 510 based on our on volume. If our costs had come in the way we expected them to, our variable, so we're our variable cost for our capitated is the number of visits for our capitated times that $15 expected cost per variable cost per visit. And so our total variable cost is the sum of those two. And then fixed cost, because we're using the expected price, that we're just going to plug in 500,000 there. And then our total flex cost is 1658. And so our flex profit would be our total flex revenue minus our total flex cost, which gives us 272. Okay, so now we've done created the flex budget. Okay, so then it asks what are the profit variance, revenue variance, and cost variance. All right, let me just going to hide this column. There we go. All right. So what's profit variance? Okay, well, we start with profit variance is we're going to go right to left, right? So profit variance is going to be the actual profit minus the static profit. Now, why are we doing actual minus static? Well, the way we set these up is a positive number is a good thing, negative number is a bad thing. And so we thought we'd have 130,000 in profits. We actually got 49,000. So we have a negative 81,000 variance, right? And that makes sense because not getting as much profit as we thought is a bad thing. So we wound up with 81,000 in profit variance. Revenue variance is done the same way because we want our actual to be bigger than our expected. So it's actual minus static. and it's negative because, and that says, well, that's bad, right? Because we wanted to have a revenue variance that's greater than what we expected, or we wanted actual revenue to be greater than what we expected. It's actually less, so that's a negative number. That's bad, right? And then our cost variance, we're going to go the other direction because we want ideally what we want is our managers to work really hard and bring in, have our costs be less than what we thought they would be. In this case, our costs were also exceeded our actual costs actually exceeded our static. Okay, so how do we check this? Well, we add. So how we can check this is we can say our profit variance should equal our total revenue, our revenue variance, and our cost variance. So if we sum those two up, we see that they do in fact add up to 81,000. So we've done it correctly. So that's one way to check your work, right? Okay, next, it asks us, the problem asks us to break down revenue variance into volume variance and price variance. Okay, so volume variance is going to be based on, we're going to hold our volume constant. Sorry, we're going to vary our volume and hold our price constant. So which two columns allow us to hold our price constant and vary our volume? Well, that's flex and static, right? Because flex is actual volume times expected price, and static is expected volume times expected price. So we're varying the volume here and holding price constant. So we're going to simply take the flex revenue minus the static revenue, and that gives us our volume variance. And then our price variance is the two columns that allow us to vary price. Well, that's these two, because flex and actual both use actual volume, but flex uses expected price, and actual uses actual price. So we take the actual revenue minus the flex revenue, and that gives us our price variance. And then to double check to make sure we did it right, we can add the two together, and they should add up to our revenue variance, and voila, they do. So that's good. Next, it asks us to break cost variance down into volume variance and management variance. So volume variance, again, is it's going to be the static variance minus the flex variance. Why? It's flip-flop now, right? Because up here, volume variance is flex minus static, but here it's static minus flex. Why is that? Because ideally we want our actuals to be lower than our expected, right? And so, so we start, our baseline is our budgeted amount or a static amount, and we want these to be lower. And in this case, the volume variance is in fact lower. Why? Because we did 77,000 visits instead of 90,000 visits. So you would expect the volume variance to be lower as a result of doing fewer visits. And it's a positive because it is in fact cheaper, right? We're not super excited about the fact that we save money by doing less work, but you know, it at least starts to explain some of the differences. But since that volume variance is so positive, it means that our management variance must be really bad, right? So management variance is going to be our flex variance minus our actual variance. Now, why are we doing that? Okay, well, flex management variance is like price variance. Now we're focused on the cost per unit. And we call this management variance because we expect the managers to be working on controlling the price per unit. And so how did we do? Well, um, our even though our volume was down, our and should have driven down the total cost. Total costs were actually more than what we budgeted for. So not only did we do fewer visits, but we really did a terrible job managing our cost per visit. It went up from 15 to 17.72, so it went up almost $3 per visit, right? Which would be like a 20% increase over what we thought it would be. So we can again double check our work by summing these two together, and they should add up to the total cost variance. And yay, they do. Okay. Now it says, E says, break down management variance into its three components: labor, supplies, and fixed cost variances. Okay. Okay, the Excel is not particularly useful here for this portion, but we're going to break management variance down, right? So the management variance was minus 235. So everything we do now has to add back up to minus 235. Let's remember, management variance is about management variance is dealing with price variance, is really price variance. And so the two columns that we're going to work with are flex, because that is actual volume times expected price, and actual, which is actual volume times actual price, right? So we're only going to use, because we're dealing with we're breaking management variance down further, we're going to be focused just on different kinds of price variances, or the components, the subcomponents of the price variance that drives this overall management variance. So the first part that even though fixed costs is the last part, it's the easiest one to deal with. So the fixed cost variance is equal to flex fixed cost minus actual fixed cost. So the flex fixed cost was 500 and the actual was 525, so that's minus 25. So that's our first component, is 25,000 of this negative 235 is explained by the fact that our fixed costs were higher than we thought they would be. Okay. Then we've got to do the slightly more complicated ones. Okay, so labor variance is going to be flex labor cost minus actual labor cost. Well, actual labor cost we can get directly from the problem, and actual labor cost is 1.242 000, right? What does flex labor cost consist of? Well, flex labor cost consists of the flexible labor cost comes from a combination of, so you're going to want the expected price and the actual volume. So the actual volume is 77,200 visits. And then the labor cost comes from the $25 per hour was the expected labor rate. And then we thought that each visit, right, if you go back to page 266, we thought that we would have to use 48,000 hours of labor divided by 90,000 visits gives us 0.533 hours per visit. So $25 per visit, $25 an hour times 0.533 hours gives us our price, our expected price per visit in terms of labor. So that's $13.33. So we thought we would spend $13.33 on labor per visit times the 77,200 visits that we actually did, gives us our flex labor cost of 102,933. So subtracting 1242 from 12029,333, we get negative 212, 667, if you will. Okay, so so far we've gotten negative 25 for fixed cost, negative 212 for labor cost, and now the last one is supplies variance, and I'm going to use a different sheet. Supplies variance is again going to be flex supply minus actual supply. So the actual supply is given to us in the problem, and that is 126,000. So where does flex supply come from? Well, we have our volume, 77,200. That's our actual volume because this is flex, and then we need a price, a supply price, and so we thought that we would be spending. If you go back to page 266, we thought we would be spending $1.50 per unit. And then times, then we would multiply that by the number of units of supplies that we would be using. So we thought we were going to use, again, going back to page 266, you can see the original projection was that they would use 100,000 units. And they thought that they would be using 100,000 units for 90,000 visits. So the cost per unit was 1.11, repeating, right? So we thought we'd use $1.50 times 1.11 units. So that gives us, so times 150 gives us 166, repeating, as our expected price, times 77,200 gives us 128,667. So our flex supply based on the expected price and the actual volume should have been 128. We actually spent 126. So in this case, they actually managed their supplies better. I guess that could be 7. So they had a positive variance of 2,667. So if we add all those up now, so we've got plus 2,667 minus 25,000 for our fixed cost variance, minus 212, 66, I think that's probably 667, gives us minus 235 and a little bit of a little bit of rounding error. And note that totals back up to our management variance. Okay, so the last part of the problem is just kind of discuss the results, right? So as a result of the changes, they had, if you remember from the spreadsheet, they had an $81,000 loss, a profit variance, a negative profit variance. So they had an $81,000 loss. That was explained by kind of about 50-50 in terms of the cost variance. The cost variance and the revenue variance. The bulk of the revenue variance came from having lower volume than they expected, but it was partly offset by earning better fee-for-service price. On the cost side, the volume variance was they should have saved a lot of money because they had a reduction in volume, right? They went from 90,000 to 77,000 visits. However, even though they went down from 90,000 to 77,000 visits, they still had a significant management variance, meaning negative management variance, meaning they spent a lot more on their on each of their units, or they spent a lot more to produce each visit than they had anticipated. And then, we then went and drilled down into each of the different kinds of variants. So it turns out they actually did a pretty good job managing their supplies. It was really the big problem they had, it looks like, is they spent a lot more on labor than they should have, or than they anticipated, and they had a modestly higher fixed expense than they had expected.